Hi everyone, welcome to the demonstration and implementation of frequency hopping example on iWave's ZU47DR based RFSoC PCIe carrier card with MATLAB and Simulink. For this demonstration, we will be using iWave's ZU47DR based PCIe card and MATLAB. For the RF part, we will be connecting the DAC output to ADC input in a loopback configuration. We connect the Type-C debug cable into the Type-C port. We connect the Ethernet cable to the ETH1 port. Then we connect the 12V 5A power supply to the power connector. This is the demo setup. Here we are using the ZU47DR SoC. Which is mounted on the PCIe carrier card. For the RF section, we have DACs and ADC connected in a loopback configurations. We also have two Ethernet ports, ETH0 and ETH1. For this demonstration, we are going to be using ETH1 port. We also have Type-C debug port and the power connector. The Type-C debug cable should be connected to the COM port of the system, and the Ethernet cable will be connected from the ETH1 port of the board to the Ethernet port of the system. Now, we'll move on to MATLAB. We start by opening MATLAB GUI. Next, we open the frequency hopping example model. Here, you can see that the Simulink top model used to generate the FPGA design. The top model consists of the processor, FPGA subsystems, memory interconnect, and the RFDC block. Next, we select our hardware target. Once the hardware target is selected, we move on to the build process. We go to Configure, Build and Deploy, which opens the SoC Builder. Using SoC Builder, you can generate the bitstream and the software executables for the model to run in deployment mode. After bitstream is generated, we can proceed to load the design onto the board. Once the design is deployed on the board, you can monitor the receiver tone on the spectrum scope in the software model. The transmitter hops between frequencies while maintaining a constant baseband tone. As the NCO frequency changes, the transmitter carrier hops across the configured frequency range. As RF frequency changes, the receiver NCO tracks the same frequency. The ADC mixer down converts the received signal back to the baseband signal and remains centered at approximately 1 MHz, demonstrating a successful frequency synchronization between the transmitter and receiver. As you can see, the output is a stable 1 MHz tone, indicating that both transmitter and receiver are hopping at the same frequency. We can also verify the hopping externally using the CRO. I have connected the DAC output to the CRO, and the Type-C debug port is connected to the system. I have also considered the DAC to perform frequency hopping in 100 MHz steps from 300 MHz to 800 MHz. Notice how the carrier shifts between the configured frequencies. This confirms that RFDC carrier frequencies are being updated in real time. In this demonstration, we successfully implemented the frequency hopping example on iWave's ZU47DR based PCIe carrier card. For more information about the hardware setup, please visit our website. Also, if you are interested in MATLAB's transmit and receive tone demo, please click on the I button. Thank you for watching.